All right, you guys ready? What? We're starting now. Sorry. All right. So the problem says, now this is, we did projectile motion before. Now we are doing a new type of problem. So it's going to feel very similar to what we did before. It's just instead of projectile motion, we're going to have a new situation. So it says an open box with a rectangular base is to be made from a piece of cardstock. So this is what cardstock is. It's like paper, it's just really thick paper. Okay, so some of you guys might have used cardstock to make crafts or something, I don't know, but it's just really thick paper. So that cardstock measures 8 centimeters by 12 centimeters. All right, so we're going to go ahead and start drawing a picture, and I want you guys to label the picture exactly the way that I label the picture, because we're actually going to draw inside the rectangle. So put the 8 centimeters outside and put the 12 centimeters outside the picture, because we are going to draw inside the picture. So this is what the cardstock looks like. They say, huh? It's from Tuesday. Okay, can you get out notebook paper? It says we're going to make the box by cutting out a square from each corner and turning up the sides. So we're going to cut a square from each corner like this. And then we're going to take each of the sides and we're going to fold them. And if you fold all of the sides up, then you can see that once you do that, you make a little box. It doesn't have a lid, but you make a little box. Does that make sense? Everyone can see how that would turn into a box? Okay, so we're going to go ahead and draw this, that we are cutting out squares from the corners. So I'm going to shade them in like this to show that I'm getting rid of them. I'm going to cut out the squares. I'm going to throw them away. And then with those pieces that I have that are on the sides, I'm going to fold them. And when I fold up those flaps, it makes a box that just doesn't have a lid. Okay, so just do it on notebook paper. Okay, so here's our box. Okay. All right, so the original piece of paper that we had a length of 12 centimeters. They're telling us for this first problem that what we're cutting out is a square that is 1 centimeter by 1 centimeter. They're telling us that's what we're doing. So if we take a square and we cut out 1 centimeter by 1 centimeter, I'm going to go ahead and label that in my picture, 1 centimeter by 1 centimeter. If it was 12 centimeters long to begin with, and I cut 1 centimeter on one side and I fold it up, and I cut 1 centimeter on the other side and I fold it up, and that makes my new length, then what would the new length of the box be? 10 centimeters. Okay, so it was 12 to begin with. I folded 1 centimeter on one side, 1 centimeter on the other side. My new length is 10 centimeters. So I'm going to go ahead and label this now. My new length is 10 centimeters. And I'm going to write down how I did that math. I started off with 12. I subtracted 1 from one side, 1 from the other side, and that gave me 10. Okay. The original width was 8 centimeters. I had the square on each side. I cut from one corner 1 centimeter and I folded up the side. I cut 1 centimeter on the other side and I folded up the side, and that made my new width. So what would my new width be? 6. Okay. So my new width is 6 centimeters. And so the math that I did for the width was 8 centimeters minus 1 on the top minus 1 on the bottom, and I got a new width of 6 centimeters. Okay, and then watch this one very carefully. I had a 1 centimeter square cut out from the corner, and I folded up the sides, and this is how the height of my box was created. So what is the height of my box? 1 centimeter. Can everyone see how I got that measurement? If the square is 1 centimeter by 1 centimeter, and I fold the flaps, it would give me a height of 1 centimeter for my box. Can we all see how that would be 1 centimeter? Okay, so for the height, we don't really have to do any math there. We just watch it happen. We just say, okay, the height is 1 centimeter. Does anyone remember the formula for volume? Length times width times height. Okay, so we're going to write volume equals length times width times height. This is the formula that we're going to be using to find the volume of the box. So for this particular problem, we're going to say, I don't know why I wrote it like that. Hold on. 10 for the length times 6 for the width times 1 for the height. And what is the volume of the specific box that we just made? 60. And it was centimeters times centimeters times centimeters. Centimeters cubed is what our units would be. So the volume of the box would be 60 centimeters cubed. All right, how do we feel about that so far? Feel good? Okay. We're going to do it again, but this time we're going to cut a bigger square out of each corner. Okay, so let's draw the picture again. Eight centimeters, 12 centimeters. And this time they're saying that they cut a 2 centimeter square out of each corner. So this time the square is larger. Do you guys think the volume of the box is going to be bigger or smaller? You cut a bigger square out of the corner. Should the volume of the box be bigger or smaller? Bigger? Okay, so we're cutting out those corners. We're going to fold up the sides. Okay. So let's start with the width. The original length was 12 centimeters. We cut out a 2 centimeter square on each side. So I cut out 2 centimeters on the left side and folded up the flap. I cut out 2 centimeters on the right side and folded up the flap. So if it was 12 originally, and I cut 2 and I cut 2, what is the new length? 8, okay? So my new length is 8 centimeters, okay? So length would be 12 minus 2 minus 2. The new length is 8, okay? My original width was 8. I cut 2 centimeters out of one side and folded up the flap. I cut 2 centimeters on the other side and folded up the flap. So what is the new width? 4. Okay, my new width is 4 centimeters. So I'm going to say width equals 8 centimeters minus 2 is a new width of 4. Okay. I have a 2 centimeter square cut out of the corner. I take the flaps and I fold them up. And what is my height? 2 centimeters is what my height is going to be. Okay, so my height is just 2. Okay, so now for the volume, I'm going to do length times width times height. What do I get? 64 centimeters cubed. Okay, so the volume of that box would be 64 centimeters cubed. Cutting out a bigger square makes a bigger volume. Okay. Now, those questions were to help us understand what we're doing because they technically weren't math 3 level questions. So when they take the problem and they make it math 3 level, they change it and they say, okay, we're going to cut out a square from each corner, but we don't know how big the square is. Okay, so that's how they're going to change the problem. So we're going to draw the picture one more time, but we're going to say that this time we don't know if the square is 1 centimeter. We don't know if the square is 2 centimeters. We don't know if the square is 1.25 or if it's 2.3 or if it's 5.8 centimeters. We don't know how big the square is. We're just going to cut out some square from each corner. And so if you don't know how big the square is, what do you call it if you don't know? In math, anytime we don't know what the number is, what do we use? If we don't know what the number is, what do we use to represent the number? An X. We use an X to represent the number anytime we don't know. So for this one, instead of saying we're going to subtract 1 and 1 or subtract 2 and 2, this time we're going to say the length is 12 minus x because we don't know how big that square is. And we're going to say the width is 8 minus x, and we're going to say the height is just x. So any place before where we knew what the measurement of the square was, we knew the measurement was 2, or we knew the measurement was 1, this time we're using an X because the math 3 version of the question says you don't know what the square is. So we're just putting an X there instead. So 12 minus X, there's 2 of them. So this is actually 12 minus 2X. There's 2 of them. So this is actually 8 minus 2X. And this one's just X. Yeah. So the volume formula is always length times width times height. And so up here, when it says write your volume formula, length times width times height, we're going to say the volume in terms of X. So written, if you find the volume based off of the size of square that you cut out, then the volume is going to be length times width times height. Length times width times height. And now we're going to use that formula, length times width times height. We're going to use that for the rest of the problems. Now, the nice thing about this is that this setup for a problem of saying, oh, you have a piece of cardstock or you have a piece of cardboard or you have a piece of whatever, and you're making a box out of it and you're cutting the corners out and you're folding up the sides. That is a very common setup for these problems. And I've seen them on the EOC and I've seen them on like SAT prep books, ACT prep books. So this particular setup, you're not going to have to do it differently. It's always going to be the number minus 2x. It won't be minus 3x. It won't be minus 4x. It won't be minus something else. It will be minus 2x. Okay. So you can set it up the same. We did this other stuff so you guys could understand how I set it up. Okay. So you don't have to do the rest of this again. You can just kind of memorize this is how it goes. Okay. All right. So let's go ahead and get this plugged into Desmos. So 12 minus 2x, 8 minus 2x, and x. And before we get started on Desmos, we're going to hit the home button because we were just using Desmos for our warm up and we want to go back to the regular settings. So go ahead and hit the home button. And then that kind of brings us back to normal. And then I can get rid of the graph that I was using and go ahead and type this one. So 12 minus 2x, 8 minus 2x, and x. And then we do want to have the table up. So how do we get Desmos to show us the table? Yeah, this little thing. And we click on it. And then we go to the table. And then we put our cursor after the 2. And we see that our volume is up here, and we just want to watch it go down until it gets to 0. So I'm going to press enter, and it goes down a little bit, and I'm just going to keep, oh, there's the volume of 0. So I only had to press enter a few times, but I just want to make sure that I have all the values here. So the biggest value that I can see is 64. And so now I want to make sure that Desmos goes big enough on the picture so that I can see all the way up to 64. And so what do I need to do? I want to make sure my screen is big enough. I need to change the values of my screen so I can see everything. You guys remember what I click on? The wrench. I click on the wrench, and I'm going to change my Y value. My X's are fine. -10 to 10 is fine for the X values because the X values don't get very big. It's the Y values that get big. So I'm going to take my Y values. I need something bigger than 64, and I'm going to go a little bit too big. So I'm going to go like 75. And that'll make it so I can see everything I need to see. And then I can just click out of that. All right. We all good? Now the table is only going to give us whole numbers for X's. We might want decimals. So I'm going to go back and I'm going to type in the equation y equals 12 minus 2x, 8 minus 2x, and x. This is just going to let me click on the maximum if I need it. It's going to let me click on the x-intercepts if I need to. The table doesn't necessarily let me do that. So I always like to have the table, but then I like to have the equation just plain typed in also. I like to have both of them. Okay, are we good? We got Desmos all set up? Okay, I'm gonna go back to my paper. Before I start answering the questions, I'm gonna go back and I'm gonna make sure that I know what X and Y stand for. So I have the X coordinate, I have the Y coordinate. The X coordinate is the size of the square, cut out from the corners. The X value is the size of the square cut out from the corners. So that's how we determined in the beginning of the problem what the X was. The size of the square that was cut out from the corners. Now, once we plug the X's into the equation and the Y value pops out, the Y value is the volume. The Y value is the volume. So just like last time when we were doing the other problems, we were thinking about, okay, the X value was the time and the Y value was the height. So this time we're going to think about, okay, the X value is the size of the square, the Y value is the volume of the box. So when we look at each question, we're going to think about which one do we need to find? Do we need to find X or do we need to find Y? Okay. All right. So let's look at question 10. It says, what is the volume? What is the volume? So are we finding an X value or a Y value? We're finding a Y value. That means they gave us an X value. What X value did they give us? What X value did they give us? 1.25. They told us how big the square was, 1.25. Okay, so now let's go back to Desmos and we're going to plug in 1.25. And there's a few different ways you can plug things in Desmos. And I usually just like to add it to the table. So I'm going to type in the X spot 1.25. So you can plug in any value that you want into the table and it will give you the y coordinate output for it. So 1.25 for x, 65.3125 for y. And I'm just going to write down that point and move on to the next question. I'm going to write my sentences in a little bit. The next question says, what is the volume if a 2.3 centimeter square is cut out? So it says, what is the volume? So are we looking for an X value or a Y value? We're looking for a Y value, and they gave us an X value of 2.3. Okay, so I'm going to go back to Desmos and I'm going to plug in 2.3. So the next one, I'm typing in 2.3. Okay. And then we have a third question. Again, it says, what is the volume? So again, we're looking for the Y value. And it says if a 4.5 centimeter square is cut out. So again, we're plugging in an X value, 4.5. Negative 13.5. Okay. So there's my 3 answers for these questions. Okay. So the volume, if a 1.25 centimeter square is cut out, is 65.3125 centimeters cubed. The volume, if a 2.3 centimeter square is cut out, is 57.868 centimeters cubed. The last question says, when you cut out a 4.5 centimeter square, does this make sense? So your volume is negative 13.5. Does that make sense? Your volume is negative 13.5. Does that make sense? How much stuff can you fit in a box with a volume of negative 13.5? Yeah. Can boxes have negative volume? No. So this question doesn't make sense because negative volume doesn't make sense. Negative volume does not make sense. All right, let's turn to the next page. We have 3 more questions to answer. All right, this says for what size square? For what size square? So are we finding the x coordinate or are we finding the y coordinate? Finding the x coordinate or are we finding the y coordinate? We're finding the x coordinate. All right. So, and it says, is the volume the largest? So are they giving us a y coordinate to plug in? What should we look at on Desmos? For what size square is the volume the largest? Where should we look on Desmos? The maximum. So we're going to look at the maximum right here. What size squared is the volume the largest? I'm going to go ahead and write down the point. So 1.569, 67.604. Okay, so I wrote that down. And what do I do now? For what size square is the volume the largest? What part of this is the answer? For what size square is the volume the largest? The x value, okay. So the largest volume occurs when a 1.569 centimeter. Will somebody answer that and say Miss Rice's room student speaking? Did they not stay there? Yeah, that happens to me all the time. The largest volume occurs when a 5.69 centimeter square is cut out. Now, they asked next, what are the dimensions of the box? What does the word dimensions mean? What does the word dimensions mean? Anyone know? Dimensions of the box. You could Google it right now. How big it is, the measurements, and what words do we use for measurements of the box? What words do we use for the measurements of the box? Length, width, and height. Okay, so we need the length, width, and height of the box. The length is 12 minus 2x. The width is 8 minus 2x, and the height is just x. So we actually know one dimension already. That's the height, because that's just 1.569. So now we have to plug x in to 12 minus 2x and 8 minus 2x so that we can find the length and the width. So 12 minus 2x and 8 minus 2x. So let's go ahead and type that in. So I'm just going to use Desmos as a calculator. So 12 minus 2 times 1.569. 8 minus 2 times 1.569. So the length is 8.862. The width is 4.862. And the height is 1.569. Okay, so to answer the next question, what are the dimensions of the box with the largest volume? The dimensions of the box (8.862 centimeters by 4.862 centimeters by 1.569 centimeters. And then the last question says, what is the largest volume? The largest volume is anyone know what the largest volume is? What's the largest volume? Because adding length and width and height doesn't give you a volume. We actually don't have to do any math because we already found it. It's already written on my paper. It's already written on my paper up here. It's the 67.604. It's the y coordinate. So the largest volume is 67.604 centimeters cubed. All right, the next question says, what size square? So if it says what size square, what are we trying to find? It says what size square? What are we trying to find? The x. What size square could be cut out that would give a volume of 50? If it says give a volume of 50, then what is that number 50 giving us? Which value is that? We're looking for an x. They gave us a number. What is that number for? Brayden, go ahead and bring your phone up here. X is what size square? What's the 50? It's the y. Y equals 50. Okay, so now let's go ahead and go back to Desmos. We need to plug 50 in for y, which means we need to graph 50. So y equals 50. And then it looks like we got 3 answers. We can cut out a 0.723 centimeter square, a 2.548 centimeter square, and a 6.693 centimeter square. One of these does not make sense. Can you, if you have a box, let's see, the box was, or if we look at, if we think about the paper was 12 inches by 8 inches in the very beginning. Can you cut out a square that's almost 7 centimeters from each corner? 7 centimeter square, 7 centimeter square? No. 7 centimeter on each side if it's only 8 centimeters wide, but 7 centimeters on each side. No. So whenever you do these problems, this answer over here is always extra. It doesn't make sense in the problem. So we're only going to look at these two. So I'm going to get rid of this one. Nope, unclick. Okay. So we just want these two answers. So I'm going to go ahead and write down both of those. We got 0.723, comma 50. And we've got 2.584, comma 50. And it says it wants us to write the dimensions for those options. So remind me, what does dimensions mean again? The measurements, the length, the width, the height. Okay, so let's go back to our sheets. I am not going to make you write sentences for this one. So we're going to say a 0.723 centimeter square. And then we're going to write the length, the width, and the height for this square, what that would be for the dimensions. And then we've got a 2.584 centimeter square. And then we're going to write the length, the width, and the height for that situation. So I already know the height for both of these because for each of these, it's just the X value. But then for the length, it's 12 minus 2X. And I have to actually plug in my decimal. And for the width, it's 8 minus 2X. And I have to actually plug in my decimal. So let's do the first one. So 0.723, 0.723, and then 2.584. And 2.584.